the mole. Now, why are we talking about this? And we're not talking about this critter that digs holes either. Here's the problem. Atoms are extremely small. If we could blow one up to make one the size of this dot, right there, that if an atom were the size of that dot, my pencil that made that dot, would have to be 100 miles long, right? And a line drawn by this pencil would be 109 yards wide, bigger than a football field. So atoms are extremely small. And since they are so small, we need to talk about them in very large numbers. Otherwise, we can't mass them out. We can't make things, practical. We can't measure them. So we need a number that's millions and billions of times larger than a dozen. And we're going to refer to this number as a mole. So just what is a mole? Well, let's start with a dozen. If you had a dozen atoms, you'd know that you have 12 atoms. What if you have a mole of atoms? Or you have a mole of anything? How many would you have? 6.022 times 10 to the 23rd. And this number is referred to as Avogadro's number. So how many carbon atoms are in 0.0038 moles of carbon solid? So we need to convert 0.0038 moles of carbon all the way to carbon atoms. Okay, so the conversion factor we need is moles of carbon to carbon atoms. Well, Avogadro's number. We know that 6.022 times 10 to the 23rd of anything, carbon atoms, would be a mole of that thing. So there it is. 1 mole of carbon, put that in the bottom. The numerator, 6.022 times 10 to the 23rd carbon atoms. Then it'll all work out because see how my units cancel? I'm in carbon atoms. So 0.0038 times 6.022 times 10 to the 23rd, about 2.3 times 10 to the 21 carbon atoms. So how do you put 6.022 times 10 to the 23rd in the calculator? Well, first, just type in 6.022, and to get the exponent, push exp. Exp means 10 to what power? So once we push it, we get little exponents to show up, 23. So now we have 6.022 times 10 to the 23rd in the calculator. The molar mass of a substance, or the mass of exactly 1 mole of a substance. Here I have a bag of salt, sodium chloride, and in this bag I have exactly 1 mole. In other words, I have exactly 6.022 times 10 to the 23rd units of NaCl. Here I have another bag with exactly 1 mole of this compound, sugar. So I have exactly 6.022 times 10 to the 23rd units of that material. How did I know how much of this material to mass to put in these bags? Okay, that's what we're going to figure out here. How do you find the molar mass of any element? The answers are all in the periodic table. For example, take a look at carbon. The number below the element symbol is the molar mass of that element. So for carbon, it's 12.0107. So that means for carbon, 1 mole of carbon equals 12.0107 grams of carbon. Or you could say 12.0107 grams of carbon in 1 mole of carbon. You'll make these conversion factors if you like, or flip it. 1 mole of carbon, 12.0107 grams of carbon. So that's how we're writing molar mass. It's the grams of the material divided by the moles of the material. And you get the molar mass of the elements from the periodic table. Okay, how do you find the molar mass of a compound like sodium chloride? So what we're going to do is add up the molar mass of sodium chloride. That's one sodium atom, 22.9898, pretty much, plus chlorine, which is 35.45, and we'll have the molar mass of sodium chloride, 22.9898 plus 35.45, about 58.44. 58.44 grams of sodium chloride per mole of sodium chloride. How about sugar? To find the molar mass of sugar, we have to take 12 times carbons plus 22 times the molar mass of hydrogen plus 11 times the molar mass of oxygen. Add them all up, and we'll have our answer, grams per mole. So let's put in those numbers. Carbon is 12.01. We're not really worried about sig fig, so I'm just doing a lot of rounding here. Carbon is 12.01. Hydrogen is 1.01. Oxygen is 16. So add those up, and I'll have the molar mass of sugar. 12 times 12.01 plus 22 times 1.01 plus 11 times 16, about 342.3 grams per mole. That'd be the molar mass of sugar. So what I did is I amassed exactly 342.3 grams and put it in here. For the sodium chloride, I massed out about 58.5 grams and put it in here. Some terminology that we need to get used to when referring to molar mass. The molar mass of sodium chloride is, we said it was 58.44 grams per mole. 58.44 grams of sodium chloride per mole of sodium chloride. Now this may also be called the formula weight. We don't say molecular weight because it's not a molecule. These are formula units. It's an ionic compound. The molar mass of sugar, we said, is 342.3 grams per mole. And this may also be called the molecular weight because it's a molecule. So how do you tell the difference between these two? Well, if you don't see a metal, element, you should be referring to these units as molecules. If you see a metal, then you should be referring to these units as formula units. 1 mole of sodium chloride consists of 6.022 times 10 to the 23rd sodium. So we see a metal. We should refer to them as formula units because they're crystals. They're sodium cations surrounded by chloride anions. They're not molecules. 1 mole of sugar consists of 6.022 times 10 to the 23rd molecules. We don't see a metal, so this has to be a molecular compound. Circle each molecular formula below and place a box around formula units. So circle the molecules, box around the formulas. So look for a metal. If you see a metal, draw a box around that compound. If you don't see a metal, draw a circle around it. So I see a metal, I see a metal, I see a metal. So I'd be drawing boxes around those compounds. And circling the molecules. So remember, metals is pretty much everything here on the periodic table and over. Those are all your metals. Mole ratios from chemical formulas. Now what do we mean by that? We're saying if you have a chemical formula how many moles of the different elements do you have in that chemical formula? What ratios can you write? And that's what we're after. For example, let's start with this iron 3 carbonate. How do you write the chemical formula for iron 3 carbonate? Iron has to be 3, so plus 3. Carbonate is just one of those polyatomic ions that you have to know, CO3, and know those charges. It has a -2 charge. That -2 becomes a subscript, and the 3 becomes a subscript. So there's our formula, Fe2CO3, 3. What mole ratios can we write? Well, for every 1 mole of iron 3 carbonate, how many moles of iron do I have? Right? For every 1 mole of iron 3 carbonate, how many moles of carbon do I have? And there's 1 left. How many moles of oxygen do I have for every 1 mole of iron 3 carbonate? These are the mole ratios from chemical formulas. So see if we can figure these out. Iron. How many moles of iron? You pretty much just look at the chemical formula, look at the subscript. We have 2 of them. We have 2 moles of iron for every 1 unit of iron 3 carbonate. How about carbon? Carbon is inside the parentheses. Do you see how many carbon atoms you have? How many oxygen atoms do you have? 3 times 3 is 9. 9 oxygen atoms for every 1 unit of iron 3 carbonate. So that means you'd have 9 moles of oxygen for every 1 mole of iron 3 carbonate. So there's my answers. What is the formula weight of iron 3 carbonate to 3 significant figures? Notice they're interested in significant figures. So we can't do any rounding into the very end. So you have to write down all the digits. So we're after iron 3 carbonate. Remember that was this formula. Iron 3 carbonate. And formula weight was just a fancy word for molar mass. You can always say molar mass. You don't even have to use the words formula weight, but you just have to get used to it. And remember, the game plan is just find these elements in this compound, find them in the periodic table, and add them all up, and you'll have the molar mass of that compound. So we have to take 2 times iron plus 3 times carbon plus 9 times oxygen, and we'll have our answer. So let's look these up. Iron, 55.845. Carbon is 12.0107. And oxygen, 15.9994. Okay. 55.845 times 2 plus 3 times 12.0107 plus 9 times 15.1234. You get about 291.7167 grams per mole. And they want to know 3 significant figures, so I can only go to 292 then. How many grams are contained in 3.7 moles of iron 3 carbonate? So we're going to start with the measurement, 3.7 moles of iron 3 carbonate. And you want to end up in grams of iron 3 carbonate. So how do we do this? use the conversion factor that we just found. Whenever you want to go from grams to moles or moles to grams, it's the molar mass. Okay? And let's just use the one that's 3 sig figs. Do we write it as 292 grams per mole or a mole and 292 grams? You better write it in this way. Otherwise, the moles won't cancel. So if I write it this way, my moles of iron 3 carbonate cancel out. I'm in grams. I'm done. So 3.7 times 292, I get about 1080.4. If I want to report my answer to the correct number of significant figures, just 2 digits, so I would have to report that as 1.1 times 10 to the third grams. The next one. How many carbon atoms are present in 3 grams of iron 3 carbonate? So we're going to start with 3 grams of iron 3 carbonate. Start with the measurement. And we have to convert all the way to carbon atoms. Okay, let's see if you see the game plan here. What we're going to do first, let these units help you out here. The grams of iron 3 carbonate have to cancel. So that has to go down on the bottom. Otherwise it won't cancel, right? Well, the only conversion factor you have is molar mass. It's the only conversion factor. And I'll put in the numbers later. So we got the moles of iron 3 carbonate right now. Then what would be next? You see what would be next? You got to get it into moles of carbon. So let's get into moles of carbon. Moles of iron 3 carbonate into moles of carbon. Okay, we haven't put any numbers in here yet, but you see what to do last? Use the definition of a mole. Okay, what numbers do you put in here to get all these conversion factors to work? Well, the first conversion factor is just molar mass. So we know that we have 292 grams of iron 3 carbonate and 1 mole of iron 3 carbonate. Right? The next conversion factor is our ratio. We know that we have, in every 1 mole of iron 3 carbonate, we have 3 moles of carbon from the chemical formula. The last conversion factor, use the definition of a mole. In 1 mole of anything, you always have 6.022 times 10 to the 23rd of them. Okay? So everything on top multiply, bottom divide, and it looks like we should report our answer to just 2 sig figs. So 3 divide by 292 times 3 times 6.022 times 10 to the 23rd. I get about 1.9 times 10 to the 22 carbon atoms. And I'm reporting my answer just to 2 sig figs because that's what my initial measurement started out with. And that's just our general rule that we're going to follow. Okay, so try this again, but this time you're after oxygen atoms. So we're starting with the 20 grams of iron 3 carbonate. Get it all the way to oxygen atoms. So the first step would be molar mass. And the next step is our mole ratio. From the chemical formula. and then Avogadro's number. So if I want to put in numbers here, I have the molar mass is 292 grams in a mole of iron 3 carbonate. In 1 mole of iron 3 carbonate, in 1 unit, I've got 9 oxygens. In 1 mole of anything, I have 6.022 times 10 to the 23rd. So in 1 mole of oxygen, I'd have 6.022 times 10 to the 23rd oxygen atoms. Top multiply, bottom divide. 20 divide by 292 times 9 times 6.022 to the 10 to the 23rd. And again, this time to 3 sig figs. 3.71 times 10 to the 23rd. Oxygen atoms. What is the mass in grams of a single boron trifluoride molecule? So this is going to be a very small number. Now, boron trifluoride is BF, how many? 3, boron trifluoride. And what we're going to do is start with the molar mass of boron trifluoride. Okay, boron trifluoride, boron is 10.811, 10.811, fluorine is 18.998. But I need 3 of them. So my molar mass of boron trifluoride is 10.811 plus 3 times 18.998. I get about 67.805 grams of boron trifluoride per mole of boron trifluoride. That's the molar mass. And it's kind of nice to write all those units because life is a little bit easier. Let's show you why. We want the answer in grams, so I'm not going to flip molar mass. I'm just going to write the molar mass with grams on top. 67.805 grams of boron trifluoride in 1 mole of boron trifluoride. So we need the mass of just one of these molecules. In 1 mole of boron trifluoride, how many molecules do you have? How many? Avogadro's number, 6.022 times 10 to the 23rd. So 67.805 divided by 6.022 times 10 to the 23rd, 1.126 times 10 to the negative 22 grams of BF3 per molecule. So pretty much, you recognize all we did to find the mass of one molecule, we just divided the molar mass by Avogadro's number. Works every time. What is the molar mass of each compound below? Remember, the game plan is just to add up the molar mass of each element in the compound, and you'll get the molar mass of the compound. Let's go ahead and try it. So the first one is calcium nitrate. So we have to add up a calcium, which is 40.078, plus 2 nitrogens. Nitrogen is about 14.01, plus 2 times 14.01, plus 6 oxygens. 6 times 16, about 164 grams of calcium nitrate per mole of calcium nitrate. Hydrogen, and there's 2 of them, so 1.01 times 2, 2.02. Now I'm being really generous with the rounding, just 3, 4 digits is really all I need, because they didn't specify. So I'm just doing some rounding. Barium phosphate. So I need 3 bariums, 137.3 times 3 plus 2 phosphorus, 2 times 30.97 plus 8 oxygens, 8 times 16, about 602. What is the mass in grams of a single formula unit or molecule of each compound above? So remember, if it's an ionic compound, they refer to them as formula units, molecular compound, molecule. But how do you get the mass of the smallest unit of a compound? You always divide the molar mass by Avogadro. When you divide the molar mass by Avogadro's number, 6.022 times 10 to the 23rd, you always get the mass of one of those units. Let's do that for each one then. 164 divided by 6.022 times 10 to the 23rd, I get about 2.72 times 10 to the negative 22 grams. Hydrogen, 2.02 divided by 6.022 times 10 to the 23rd, about 3.35 times 10 to the negative 24 grams of hydrogen. That'd be 1 molecule of hydrogen. Very small numbers. 602 divided by Avogadro, 6.022 to 10 to the 23rd. About 9.997 times 10 to the negative 22 grams. So they didn't care about sig figs, so I just kind of rounded where I wanted to. Usually 3 or 4 digits is good. So the game plan with this material is pretty much you can find the molar mass of any compound by using the periodic table. Just add up the molar mass of each element present in that compound. And then what that molar mass means is that you have exactly Avogadro's number, or 6.022 times 10 to the 23rd units of that compound is the molar mass of that compound.